Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to learn algebra. Today is our lesson number 43. Day number 43. We are learning right now how to add and subtract algebraic expressions. So here's the problem for day number 43. We are asked to subtract (7) a to the fourth minus 3a cubed minus 7 plus 2a squared plus 5a. Subtract this expression from the expression that is given to us here, negative 6a plus 3 plus 5a to the fourth minus 2a cubed plus 3a squared. Well, two things we have to keep in mind. First thing we have to keep in mind is that when we are subtracting one expression from the other, it's just like subtracting one number from the other. So if we are told to subtract 7 from 10, if the question is presented like this, 7 from 10, even though 10 appears later in the sentence, subtract 7 from 10, 10 appears later in the sentence, still the 10 has to go on the top, 10 has to go first, and then subtract 7 from 10. The expression that we are subtracting from has to go on the top, and the expression that is being subtracted has to go on the bottom. So that's the first thing we have to do here. So this expression from where we are doing the subtracting has to go first. Another thing you have to keep in mind is that convention dictates, convention means tradition, custom, convention. The word convention means tradition. Conventional means traditional. The word convention also has the meaning of gathering or a meeting. That's the first meaning of the word convention. But the word convention also means tradition. I want to confirm that it was day 46 when I did it. Yes, day number 46. If you want to learn it properly, just type in this tag Keshwani Prep -vocab day 46, and you will learn the word convention. I have on YouTube, just like you are watching right now, algebra videos. I also have vocabulary videos, and I also have geometry videos. Just type in Keshwani Prep -geometry day whatever, and you will find all the geometry videos. So convention dictates, tradition dictates that we write our exponents. Algebraic expression is to be written either in ascending order of the exponents or the descending order of the exponent. Ascending order as in increasing order of the exponents go up from 1 to 2 to 3 and so forth, or descending order of the exponents. This is neither. It has a here and a to the fourth here and a to the second there. It's all mixed up. So let's put it in a descending order, decreasing order. So this guy is going to go first. 5a to the fourth. That's the fourth power. Then let's do the third power right here. Negative 2a cubed. Then it's going to go. Then we will have second power, which is right here. Positive 3a squared. Then we'll have first power, which is right here. Negative 6a. And finally we'll have plus 3. Technically this has the power of 1, and technically plus 3 has the power of 0. A to the 0. Any number raised to 0 equals 1. Right now, if it feels like I'm brushing something off very quickly, is because I'm assuming that you have watched the previous videos. I do not have a luxury of keep repeating the same thing over and over again every day. Not only it will take too much time, but it will bore the hell out of people who have been watching all the videos. So if you do not know what I'm talking about, or if you feel like I'm going a little bit fast, make sure that you watch all the videos in proper order. That's how you're going to learn it. Any number raised to 0 is 1. So this is actually 3a raised to 0. A raised to 0 is 1. 3 times 1 is 1, which is why it's just 3. So now we write the other expression that we are doing. So this is the expression that we are subtracting from. And now from that, we're going to have to write the expression that is being subtracted. The expression that is being subtracted is this right here. 7a to the fourth minus 3a cubed. So far so good. And then we have to go 2a squared, 2a squared. Then we have to go 5a, 5a, and then minus 7. Now that the expressions are written properly in the descending order, or is it ascending order? In the descending, it doesn't matter whether it's ascending or descending, as long as there is a system, there is a rhythm, it's okay. They have to be arranged either in the ascending order or descending order. But most people prefer to put them in the descending order. They start with the largest power first from the left, and they go down. But if you did it in the other way, nobody's going to complain about it, it's okay. But this is the preferred method. Now that they are arranged in the proper descending order, and all the like terms are lined up properly, a to the fourth is underneath a to the fourth, a cubed are lined up, everything is lined up. All we have to do now is to go there and understand, since this expression is being subtracted, all the signs have to be changed. All the signs of the coefficients have to be changed. This positive becomes negative, this negative becomes positive, this positive becomes negative, this positive becomes negative, this negative becomes positive. And now all we have to do is just add up the exponent, add up the coefficient. I have a very high tendency of saying exponent when I mean to say coefficient, and vice versa. I don't know why I do that. It's a very bad habit. It just slips out. So now all we have to do is to add up the coefficient. We have positive 5 and a negative 7, so we get a negative 2, a to the fourth. A negative 2 and a positive 3, so we get a positive 1, a cubed. Even though if it's 1, we don't have to actually write it. Positive 3 and a negative 2 is going to give us, again, negative 1, a squared. Negative 6 and a negative 5 is going to give us 11a. And a positive 3 and a positive 7 is going to give us 10. That's it, that's your answer. First thing first, if the coefficient is 1, we don't actually have to write it. If the coefficient is 1, we don't have to write it. Everybody knows that if there is no coefficient written next to it, it's 1. Because, oh, how many p's do you see? Only 1. If I had 3 p's, I would have told you 3 p's. How many n do you see? Only 1. If I had 4 of them, you would have seen 4 there. How many x do you see? 1. I think you get the idea. I was planning to go through the whole 26 of them, but I think you get the hang of it. Anyway, so that's it. That's our answer. This is our answer. Let me make sure that I have the same answer in my notes here. Negative 2a to the fourth plus a cubed plus a squared minus 11a plus 10. That's it. That's exactly. Now we're going to do the same problem in a different method, in a second method. This is one method where you line up one expression and the other. And the other method that we're going to do is the horizontal method, where you write one expression and then you write next to it, you write the other expressions. We'll do that on top here. I need the room, so I need to raise this thing. I don't want to do it in the bottom, it's too low. And I don't want to erase this thing because we want to compare the two methods. So let's do the second method now. The second method is, let me change the marker. This marker is dying, I think. We write the first expression right here, 5a to the fourth minus 2a cubed plus 3a squared minus 6a plus 3, and from this expression we're going to subtract this expression, 7a to the fourth minus 3a cubed plus 2a squared plus 5a minus 7. What's going to happen? This has a plus sign in front of it because there is nothing there. If there is nothing, it has a plus. So this is just going to come down the way it is, 5 to the fourth minus 2a cubed plus 3a squared minus 6a plus 3. Now the game starts, the fun starts now. Pay attention. There's a negative outside and there's a positive, and negative times positive is going to become negative 7a to the fourth. I'm going to write this thing a little bit lower so I have the room to do, because I have no room on the top to put my thing. So negative times positive is negative 7a to the fourth. Negative times negative is positive 3a cubed. Negative times positive is negative 2a squared. And negative times positive is negative 5a, and negative times negative is positive 7a. What did you notice? We noticed that all the signs changed. All the signs changed. This has a positive. This guy had a positive sign. It became negative. This had a negative sign. It became positive. This has a positive sign. It became negative. It has a positive sign. It became negative. It has a negative sign. It became positive. Just like here. That's what we were doing here. Positive sign, positive 7a became negative 7a. Right there. Negative 3a cubed became positive 3a cubed. You see, negative turned into positive. Positive 2a squared became negative 2a squared. Right here, we changed the sign. Positive 5a became negative 5a. And negative 7 became positive 7. You see right here, positive 7. And now, all we have to do is just add the exponents of the like terms. Not all the exponents of the like terms. So let's do it together. I need several different colors in my hand, ready to go. So, here we have 5a to the fourth, and here we have negative 7a to the fourth. Positive 5 and a negative 7 is going to give us, positive 5 and a negative 7 is going to give us negative 2. Right here, negative 2a to the fourth. Negative 2a to the fourth. Then we have negative 2a cubed and a positive 3a cubed. A negative 3 and a positive 3, negative 2 and a positive 3 is going to give us positive a cubed, positive 1a cubed. Then we have positive 3a squared and negative 2a squared gives us positive a squared. Then we have negative 6a and a negative 5a. Negative 6a and a negative 5a is going to give us our negative 11a. And finally, a positive 3 and a positive 7 is going to give us a positive 10. You see, we get the same answer. We get the same answer. Of course, we're going to get the same answer. There are two different methods. And of course, two different methods do not give two different answers because they would hardly be called two different methods. There will be two methods. One of them will be right, and another one will be wrong. That's what it would be. There are two different methods, equally applicable, equally usable, equally correct. I will see you tomorrow on day number 44. As I said, we'll keep on chugging until we get to our destiny, which is to get to the word problem. But I don't want to jump to it. I want to make sure that you have a solid foundation before you get there. And once we get there, you will have fun. You will learn algebra, and you will appreciate algebra, and you will begin to tackle word problem like that, and it will no longer be a foreign language. Do you understand? The word problem in English language will always be foreign language to me, but not to you anymore. I'll see you tomorrow on day number 44. Bye now.